have only one element. Next two rows up have two elements, then three elements. This is an inverted flip it over, it's an inverted staircase. Each step being 2 rows high, and of course, except for the very beginning, it can be 1 or 2 depending on whether n plus 1 is odd or an even number. Okay? So if I have some that is A6, A6, S to the 6, and so on, the root array would have 7 rows, and it would be 1 element the last 2, 2 elements the next 2, 3 elements the next 3, the next 2, and 4 elements the first. Clear, everyone? Okay? Okay. Joy is nodding for this. Last bullet I put on the structure. All corners have the same value. So that saves a lot of work. When you have this structure, this is the first column, which we get immediately very easy, without any calculation. So this is a corner, now these two, same value, this is a corner, 2. So we really need to calculate only these 2 elements, only these 2 values. Okay? So that's a shortcut. You don't need to be calculating corners. All corners have the same value. You can see the result. I mean, you look at this, because it's the blank 0 here. On a corner, what you have is you have the column to the right blank. And because of that blank, you will get cancellation and you'll get back the value.
Can you repeat what you just say about the corners?
That all corners have the same value.
Oh.
So that's an easy shortcut. Okay. All right. That's all I want to say for the construction. Now, I said it's a good tool for telling us how many positive roots we have. So, number of positive roots. I'll erase that. Okay, everybody clear on the construction? Any question? So, okay to erase?
Yeah.
Very nice. Number of roots with positive is equal to number of sign changes in the first column of the first. So, we look at the first column of the roof array. That's the first column. And we look at the signs. Plus, plus, minus. There's a sign change here. The first column here has signs plus, plus, minus, back to plus, back to plus. How many changes in sign I have? No change here. Plus, minus, that's a change. Minus, plus, another change. Plus, plus, no change. 2 changes. This GU would have been unstable with 2 positive roots. Clear?
No.
Huh? No?
No. Can you
Look
explain that
how
one?
many changes in sign I have.
I only see one.
Plus minus change,
Oh, okay.
minus plus another change. How about this one? Ah, I don't mind breaking the white chalk, but I mind breaking the color chalk. How many positive roots we have here? One. Here I have only one sign change. Now, the reason I didn't want 0 on the cubic term is because I would have had a 0 in the first column. What if you have a 0 in the first column?
It's possible.
If you have a 0 in the first column, that means there is 1 or 2 roots, usually 2 roots, but depends on where it's located, with 0 real part. The 0 real part results in zeros in the first column. And how many roots you have with 0 real part? Change that 0 to a plus, change that 0 to a minus. See how many positive roots you would have. The difference between the two is how many zeros you have. So, for example, if I had what I'm showing here, suppose that I had, okay, to erase this, everybody got the example written, right? Let me erase that. Suppose that I had plus, minus, plus, plus. Positive 0, sorry, I meant 0 and I said minus. Plus 0, plus, plus. How many 0 roots I have? Consider now both with this as plus and with this as minus. If this was plus, how many sign changes I would have? 0. If this was minus, how many sign changes I would have? 2. So in this case, I have 2 roots with 0 in. What if I had this? If this was plus, I would have 0. If this was minus, I would have 1. I have 1 root with 0. And by the way, we have implicit, right? All minuses. Okay, how about this guy? Okay, let's take this guy. How many roots positive real part, negative real part, and 0?
I just have a question.
Okay, that's the question.
What's the point of making it positive?
Well, I want to find out if my system is open loop state.
Yeah, but we're always going to take the assumption of the negative.
No. I need to find here. I'm asking you that to you. Is this stable or not? Can you tell me? Not really.
When we're dealing with the zeros.
Yeah, suppose that I had, well, okay. The point is saying that if I have a 0 there, I won't be stable. Okay, point A. Okay. So, what will be the case here? Let's take this here.
You have 4 results, right?
Well, first of all, how many rows I have here? 3, 6, 7. So that will be for the 6th of the polynomial. So there are 6 roots. Right? If I have 7 rows, that means n plus 1 is 7, so n is 6, so I have a total of 6 rows. So, about this 0, if it was plus, I would have 2.
I got 3. Oh, wait, unless I added.
Okay? Okay, let's take one at a time. If it was plus, I would have 2 sign changes here. If it was minus, I have no sign changes here.
And you just neglect.
So that gives me, that means I have 2 0 roots. How about this guy? If it was plus, no sign change. If it's minus 1 sign change, so this is 1, 0. What about the rest of them? For the rest of them, take the situation where this would be minus and this would be plus. How many sign changes I have here? 1, right? So 1 positive root. So since I have a total of 6, this is a case where I would have 3 zero roots. 0 real part roots. It could be complex conjugate pair, okay? That means 0. It's a complex conjugate pair. It could be plus or minus 5i. Okay? 0 real part. So 3 0 real part. 1 positive real part. And 2 negative real part. So this would be the sign of the roots. So this is a tool to tell us how many roots of different sign for the real part we have. Of course, the implementation here, what we really care about is how many non-negative roots we have. Caitlin, question.
How did you determine how many positive and negative?
Yeah, I'm lost.
Okay. So for positive and negative, change the 0 to what gives you the fewest sign changes. Okay? So
Fewest.
here minus give it the fewest sign changes, here plus give it the fewest sign changes. Okay? So originally I have 0 and 0. First determine what's the difference in roots going from plus to minus. That difference gives us how many 0 roots. So this gives me that I have 2 0 roots, this gives me that I have 1 0. Then put the sign that gives you the fewest sign changes. Okay? So in this case, the sign that gives the fewest sign changes would have been minus. In this case, it would have been plus. Okay? That's it.
But those signs are the first
I'm
column.
lost.
Right. First you make the root hierarchy.
Whatever.
First you have to make the root hierarchy.
But how would you change a 0 to a negative? Like, you said that you change it to the part where it gives you the least sign changes.
Yeah, actually, and I should say something also. I would have had a problem with construction with this, because if you have a 0 here, how can you divide by that level? So, basically, okay, let me, I think I'm confusing you with the zeros.
Yes, you are.
We don't have to worry about the zeros. Here's actually the better thing to say about the zeros. Instead of a 0, put an epsilon. Okay? Put an epsilon for every 0 that you have. And calculate the results with epsilon positive and epsilon negative, and you take the difference for what the 0 will be. Okay? So here, let me write that down. Okay.
I don't understand the 0 part.
Because it's 6.
If a 0
3 plus 1
would
is 4, and 6 next one.
I have
appear
no idea. I don't
Yeah,
understand.
but it's in plus
in the
1.
first column,
So it's 7 that you have to subtract that next to get
and we cannot divide by it, replace it
So the matrix is 5.
By us. okay, and let's say the
So the reason
what would be happening.
the reason you have 2 is because you don't
With positive or negative. Okay, so let's just say that do it with epsilon and then see how many sign changes you have with positive epsilon, how many sign changes you have with negative epsilon. And the difference is how many you have with zeros, okay? And positive and negative, use the epsilon that has the smallest sign change, the smallest number of sign changes to make the judgment of the rest of the roots, how many have positive real part.
Could you do an
Sample.
example here with multiple zeros? Like I understood when it was 1 0
Yeah.
and multiple zeros.
Okay, so,
Yeah.
what did I have? I had plus, 0, no, I had minus,
I think minus.
0, plus, 0, right? That's what I had?
It was 3 minuses. It was 3 minuses, a 0, and minus plus 0.
Okay,
And then-
so,
It was minus after the first 0.
minus, okay. All right, so with an epsilon 1, make it minus. Actually, you wouldn't have been able to generate that because you would have to divide by that, so you would already put an epsilon 1 here. Okay, epsilon 1. Yeah, the point that I was going to make, this you could have, because you're not dividing by that with this. But this, we have created a problem generating the rest, because for this one, you would need to have the denominator as 0. So you would run into a problem here. So you would put an epsilon right away here. Wait a minute. So you would replace that with an epsilon right away for the computation below. So that would be an epsilon 1, that's it, minus plus epsilon. Okay? So, okay, so that's what you would do. You would have epsilon sub 0. Okay? Difference between epsilon I positive and epsilon I negative gives number of 0 positive real roots. Okay, so in this case, epsilon 1 positive would give us 2, epsilon negative will give us 0, so here I would get 2, 0 real positive. Here, positive with Andrea, you understand me? Okay. You understand that instead of zeros I have epsilon, right?
Yes.
Okay. If that epsilon 1 was positive, how many sign changes would I have? Minus, plus, plus, minus 2. If this was positive, I would go minus, plus, plus, minus. That's 2 sign changes. Clear? If this epsilon 1 was negative, what would I have here? Minus, 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 minus. 0 sign changes. So if it was positive, it would give me 2. If it's negative, it would give me none. The difference is 2. So this here means I have from here 2 roots with 0. Down here, epsilon 2. If that's positive, how many sign changes? Andrea, if that's positive, how many sign changes have here? Andrea, sign change means from minus to plus, that's a sign change. Plus to plus, no sign change. That's what sign change means. I'm comparing signs as I move down the column. So if I have minus here and the next one is plus, that's a sign change. Plus and the next one is plus, that's no sign change. If it's another plus here, no sign change. If now becomes a minus, that's a sign change. If it becomes plus, another sign change. Clear on the sign change? Okay, now, I have here epsilon, minus, minus. If this guy was plus, how many sign changes I have? Minus to plus, 1, and plus to minus 1. So 2 dots. If this guy was minus, minus, that's no sign change, minus, no sign change. So with plus I would have 2, with minus I have none, difference is 2, 2 zeros. Down here, epsilon 2. If it was plus, no sign change. If it was minus, 1 sign change. Difference is 1, 1, 0.
So the difference is -1. It's absolutely.
Larger minus smaller. And by the way, well, okay,